Glycogen metabolism. The metabolism of glycogen in animals. Glycogenesis, formation of glycogen, de novo or in large. Glycogenolysis, mobilizing glycogen. Dietary glycogen breakdown, structure of glycogen particles. Glycogen can represent up to 10% of the weight of the liver and 1% to 2% of the weight of the muscle. The elementary particle of glycogen, B particle, is about 21 nanometers in diameter, consists of up to 55,000 glucose residues with about 2,000 non-reducing ends. 20 to 40 of these particles cluster together to form A rosettes, figure 15.2, p. 562. Glycogenolysis, mobilizing glycogen. While liver glycogen can be depleted in 12 to 24 hours, muscle glycogen will not last for an hour. Glycogenolysis. To mobilizing glycogen, 3 enzymes are required: glycogen phosphorylase, debranching enzyme, and phosphoglucomutase. The end product of glycogenolysis is glucose-6-phosphate. Glycogen phosphorylase uses inorganic phosphate to attack non-reducing ends. Phosphorolysis, debranching enzyme. Debranching enzyme transfer the as whole from the branch to the main chain, then it will use its I16 glucosidase activity to hydrolyze the from glycogen for glycogen phosphorylase. Phosphoglucomutase. Phosphoglucomutase uses its phosphorylated C residue to convert G1P to G6P. Glucose-6-phosphate. G6P formed in the muscle can enter glycolysis, energy source. G6P formed in the liver will not enter glycolysis. Instead, it is transported into lumen of the ER, where it will be converted to glucose by glucose-6-phosphatase, glucose-6-phosphatase. Glucose-6-phosphatase converted T1 transported G6P to glucose and pi. Then glucose and pi are transported to cytosol by T2 and T3, and glucose leave the hepatocyte by GLUT2 transporter. Glycogenesis, formation of glycogen. Glycogenin, glycogen synthase, glycogen branching enzyme, and UDP glucose pyrophosphorylase are required for the formation of glycogen. Glycogenesis. Glycogenesis can be separated into two issues: formation of new glycogen particle and enlargement of existing glycogen particle. Both of them require UDP glucose as precursor, which is synthesized by UDP glucose pyrophosphorylase. Formation of UDP glucose. This reaction is irreversible because pyrophosphate is removed by inorganic pyrophosphatase as soon as it was generated. Enlargement of existing glycogen particle. Branching by glycogen branching enzyme. Glycogen branching enzyme transfer of a terminal fragment of 6 or 7 glucose redisuse from the non-reducing end of a glycogen branch having at least 11 residues to the C6-hydroxyl group of a glucose residue at a more interior position of the same or another glycogen chain. Formation of new glycogen particle. Although glycogen synthase can enlarge existing glycogen particles, it cannot synthesize new glycogen particle because it need non-reducing ends from existing glycogen as primer. Glycogenin serves as primer for synthesis of new glycogen particles.